learned with quadratic so far? So remember that a quadratic has the standard form of ax squared plus bx plus c, and standard form would be set equal to 0. Remember, a, b, and c are the coefficients in front of the variables. A is in front of x squared, b is in front of x, and c is our constant coefficient. We know how to find the axis of symmetry. It's x is equal to negative b over 2a, or I like to say x is equal to opposite of b over 2a. You have a dotted line at your axis of symmetry, at that x value. Then to find the vertex, you'll use that axis of symmetry x value, plug it into your function to find your y value at your axis of symmetry. So you plug it in, you'll get some value for y, that's your vertex. And then your y-intercept is always when x is equal to 0, so you plug in 0 into your function, and it's going to give you the y-intercept where it's crossing the y-axis. And then we learned how to find the zeros, where it's crossing the x-axis. And we learned how to do that when missing the x, so if we have it of the form ax squared plus c, and then we learned how to solve a quadratic by factoring. So any questions on any of this so far? Alright, so continuing. So today is 6-6, and we're going to be completing the square, it's called. Once again, it's called completing the square, and you'll see why in just a second. So first of all, understand quadratics have the standard form ax squared plus bx plus c. We know that. Today we're going to be taking a quadratic that's in standard form and we're going to convert it to vertex form. So this is vertex form. A times x minus h squared plus k. So once again, a times x minus h squared plus k. Today we're not going to get into what each of these things mean. You're just going to take it from standard form to vertex form. And then later on we'll learn what this all means. But why do we care? Like, why do we want to change something from standard form to vertex form? Well, first of all, it's way easier to graph. Second of all, it's easier to solve. Once again, and then importantly is on the end of level test, they'll literally give you a quadratic in standard form and say, write another form of this quadratic. So what you would do is put it in vertex form. Because vertex form and standard form, they're equal quadratics, just in different forms. So something in vertex form can be written in standard form. Something in standard form can be written in vertex form. And you're actually going to have to switch back and forth at the end of level test between the two. So we're going to practice today going from standard form to vertex form. Alright, here are the steps. Take a picture of it. We probably don't have time for you to write it down, but you'll want to follow these steps. Standard form to vertex form. So our first step is to make sure your a value is 1. If not, we're going to fix it by factoring it out. So today we're actually going to have all a values of 1. So then, second, you have to also make sure, this is the most important thing, make sure your quadratic is set equal to 0. Just like if it's in standard form and we want to solve, we have to make sure it's set equal to 0 in standard form. We need to make sure it's set equal in standard form before we switch it to vertex form. Then second, find the value that makes a perfect square. So this is where the square part comes in. We're going to find the value that makes it a perfect square. So it's going to factor to become a perfect square. And this is the formula you take. You take your b value, divide it by 2, and then you square it. So that's what I'm going to call square. So this is going to be our square. So our square is equal to your b value divided by 2 squared. And we're going to insert a fancy 0. So we're going to, third step, once we found our square, we're going to insert our fancy 0 into our quadratic after the bx value. So we're going to insert that fancy square after bx. And what I mean by fancy 0 is we're going to add our square. But if we add our square, we've got to subtract our square. Because we can't just magically change the quadratic. And if you add the square, you've changed it. But if you add a square then subtract a square, isn't that just 0? So it's just inserting a fancy 0. And you're like, well then what's going to happen here? And I'm going to show you. And then fourth, the fourth step is to factor the first 3 terms in the quadratic, and then you'll add up the last 2 terms. So it's kind of a long process right now. I promise it will seem easier as we go. It's kind of a lengthy process at first. Okay, so today we're not going to be, notice on your, if you look at the worksheet, it says solve each equation by completing the square. Today we're literally just completing the square and putting it in vertex form, because you have to be able to do that to be able to solve it. So it just takes a lot of practice to be able to switch from standard form to vertex form. So we're not going to solve today. We're just going to change from standard form to vertex form. And then tomorrow we'll learn how to solve once you've done that. Does everybody understand what we're doing today? Okay. Ready for the first example? Okay, number 14 is where I'm going to start. So it says, write the quadratic in standard form to vertex form by completing the square. So once again, what we're doing when we're completing the square is we're just taking this quadratic that's written in standard form, ax squared plus bx plus c. It's set equal to 0. First step, make sure it's set equal to 0. If not, fix it. So now we're going to go ahead and we're going to write it in vertex form by the process I just gave you before. So the first thing we've already done, we've made sure our a value is 1. It's in standard form and it's set equal to 0. So then our second step was to complete the square, right? So we're going to find out what's our square. Well, the formula for square is b divided by 2 squared. So what's my b value?
4.
4, right? ax squared plus bx plus c. So my b value is 4. Now, if you show your work, there's a little trick that I'm going to give you in just a second. It really is beneficial to show your work here. So 4 divided by 2 squared. All right, now show your work. I promise it'll pay off. What's 4 divided by 2? Okay, so 2 squared. Now notice I'm showing all my work here because I'm going to use this stuff in just a second. What's 2 squared? 4. Okay, good. So our square is 4. We're inserting that square after bx. So everybody, put a star after bx. You're going to need some paper today. You can't fit it on that little guy. So after bx, we're inserting our 4, or we're inserting our square. So we still have all this stuff in front right here. We still have x squared plus 4x, and then we're inserting that exactly how it is. So it's positive 4. So I'm going to add 4. Well, if you add 4, you've got to subtract 4. Because you can't just magically add 4. Does that make sense, everybody? So does everybody understand that I'm adding the 4? I'm adding the square right here. So I'm going to add 4. Well, if you add 4, you've got to subtract 4 to even it out. Because you can't just magically add 4. And then don't forget about we still have this plus 3. And it's equal to 0. Is everybody comfortable up to here? So we added our square. So I like to, when I start, understand something. I added a square. That's my square. I subtracted my square. Does everybody see how I added the square and subtracted the square? Okay. So our next step, once we've done that, is group the first 3 terms and factor. Group the last 2 terms and add. So the first 3 terms we're going to factor. The last 2 terms we're going to add. So now factoring this, we could go ahead and say what multiplies to be a times c and adds up to be b. That's a long process. We can do that. We know how to do that. But here's a trick for you. Everybody, it's always going to factor to be what was before you squared it. It's going to be that twice. So everybody, do you see how we have a positive 2? The b divided by 2 is 2. Does everybody see how it's positive 2? So we could go through and factor this the long way, or we could use this trick. The whole reason of completing the square is so for this reason, exactly. This is positive 2. So this is going to factor to be, why isn't my pen writing? Just a second. Okay, so this is going to factor to be x, since it was positive 2, it's going to be plus 2, and it's going to be that twice, so squared. So we could have factored this a long way. We could have said what multiplies to be 4 and adds up to be 4, right? 2 and 2, we could have done it the long way. But it's always going to be what was inside before you squared it twice. So it's x plus 2 squared, and then we're going to add up. So we factored this using a little trick. We looked back inside before we squared it. It was positive 2. So it's x plus 2 squared. Then we're going to add these up. Negative 4 plus 3. Negative 1. And boom, it's in vertex form. So there's our quadratic. It was in standard form here. It's now in vertex form. And once again, tomorrow we'll learn how to solve something like this. Now, why would we want it in this form? It's way easier to graph. It's way easy to solve. So this is like really an ideal form. And then once again, on the end of the little text, we'll simply say, what's this in standard form? Or write this as another form, and you would multiply it out. And then, so let me show you if we went backwards how we'll end up back at standard form here. Just so that we have a deep understanding. So now it's in vertex form. We've rewritten it in vertex form. Now understand, this and standard form are equal. Because if I was to remultiply that out, we know this is x plus 2 times x plus 2, right? Is everybody following me? So you understand what's going on here. Then we have minus 1. So if we multiply this out, we'll get x squared plus 2x plus 2x plus 4. And then we still have our minus 1, right? So combine like terms, x squared plus 4x from those, and then plus 3. So do you see how you can go backwards, back and forth, switching back and forth, everybody? Okay, so let's do another one. So that's all we're learning today. It's just kind of a process. Let's do another one. Okay, number 11. We're going to do number 11. You're going to want some room. So just follow your steps. First of all, make sure it's in standard form. ax squared plus bx plus c, it's got to be set equal to 0. Well, it's equal to 15, so let's fix it. So I'm going to subtract 15 from both sides. So I have a squared minus 2a minus 15 is equal to 0. And now I can begin. First check, is my a value 1? It is. Okay. Like I said though, today all of our a values are going to be 1. Okay, so we can go ahead and find our square. So our square is b divided by 2 squared. So b is negative 2. So we're going to take negative 2 divided by 2 squared. Remember, it's beneficial for you to show your work. Negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. So that's our square, guys. Our square is positive 1. So after your bx value, which would be after this 2a, we're going to add our square. So I'm going to write it out like this. A squared minus 2a. We're going to add our square. We're going to subtract our square so that we're not changing it. We're just adding in a fancy 0. And then we still have minus 15. Does everybody see where I inserted it in? After bx, our fancy 0. So our square was 1. So put in your 1. And then we can continue. So you group the first 3 terms and factor. Group the last 2 terms and add. So let's factor these. You could do it the long way, or you could say, I know a little trick. I'm going to look back what b divided by 2 was before I squared it. It's going to be that twice. So this is going to factor to be a, because it's negative 1, it's going to be minus 1 squared. We've set it up to be a perfect square. That's what a perfect square looks like. Something multiplied by itself twice. Does everybody understand where I got that? And then we're going to add these 2 up. Careful, this is negative 1 plus negative 15, which is negative. So we have negative 16 is equal to 0. And now we have it written in vertex form. So it's not super hard, it just takes practice, takes being precise. Okay, questions? Okay. Number 8, last one, because you're not always going to have whole numbers. It's going to sometimes come out to be fractions. So here's an example of when dealing with a fraction. So we're doing number 8 together. So once again, first step, if it says, like if we're rewriting this in vertex form, we've got to make sure it's set equal to 0 and in standard form. On number 8, it's equal to negative 4. So I'm going to add 4 to both sides. So I have p squared minus 5p plus 4 is equal to 0. And then I can continue. My a value is 1, so I can start going. I'm going to find out what my square is. It's always b divided by 2 squared. My b value is negative 5 divided by 2 squared. So negative 5 divided by 2, that's a decimal. We would rather leave it as a fraction. Does the fraction simplify? Does negative 5 divide by 2? No. So we'll leave it as a fraction. We will leave it as a fraction. All right, now type it into your calculator if you need to. What's negative 5 squared? Or a trick is you can square the top, square the bottom. But you can just type it in. Negative 5 in parentheses divided by 2 squared. You get a decimal, change it back to a fraction. What do you get? Good. So 25/4. That's absolutely correct. So our square is 25/4. So we're going to insert our fancy 0 after our bx value, which will be after that value. So we're going to have p squared minus 5p. Then we add our square. But if you add the square, you've got to subtract the square. So that it's really just a fancy 0. And we still have our plus 4 equal to 0. Then from there, we know that our square was 25/4. 25/4. Then you group the first 3 terms and factor. Group the last 2 terms and add. So we know this is going to factor. Well, we haven't ever had to factor fractions, but we know a trick. You always look back inside the parentheses before you squared it. So it was negative 5/2. So this is going to factor to be p. Since it's negative 5/2, it's going to be minus 5/2 squared. And then we're going to add this up. Negative 25/4 plus 4. Don't forget the negative. So type it in. Negative 25/4. Hit enter. Plus 4. You get a decimal. Change it back to a fraction. Negative 9/4. So minus 9/4. And now it's in vertex form. So are we all comfortable, ready to try it by yourself? Okay. Awesome. Okay, so questions before we get going. Go through your process here. Write all of them in vertex form. Check with me. Okay, so you're doing 7 through 18. Go, go, go. So, common mistakes are they forget the negative right there. They forget the negative right there. They forget the negative right there. So just be really careful because that's one of the biggest, most common errors. So just keep that in mind. On number 5, if you read the instructions for 1 through 6, it says, find the value of c such that each expression is a perfect square trinomial. So this time we're just finding our square. So we have w squared plus 8w. Another way to think of this is really just having this. W squared plus 8w plus 0. That's what you can think of it as. And now we're going to find the c value that makes this a perfect square. So we can take our b value. So we're going to find our square. Our square, which is b divided by 2 squared. Our b value is 18. 18 divided by 2 squared. You show your work. 9 squared is 81. So that's our square. So, what? So this is our square, right? This is our square. So this is where we would be going. Okay, we insert that after our bx value. So we'd be doing w squared plus 18w. Then we do plus 81. You add your square, subtract your square. And then we have technically a plus 0. So then we could factor this. And we know it's going to factor to be what was inside before you squared it. So it's going to be w plus 9 squared and then minus 81 because we're going to add these two up. But really, we didn't have to go clear that far. I just wanted to show you what we're looking at here. It said, what's the value that makes this a perfect square? And it was, we added what? 81. But the only reason I like to go all the way is because people think they forget that if you add 81, you got to subtract 81. But the value that makes this a perfect square trinomial would be c is equal to positive 81. So this would be where you could stop. As long as you understand, you can't just magically add an 81. You have to subtract 81. Does everybody see what I'm saying? That's why I went a couple steps further. So you're right. The value is 81, but you couldn't just insert 81 and stop. You'd have to add 81, subtract 81. But the answer is c is equal to 81. Does everybody understand what I'm saying here? Yes. Okay. Sweet. So now you should do problems 1 through 6. 1 through 18 is going to be due tomorrow. So up through 1 through 18. That's what's due tomorrow. You have to have those done. We're moving on tomorrow. So you have 30 minutes, 20 minutes, I lied. You have 20 minutes. You should all be able to finish this by then.
Very good. Try. My heart